Ladies and gentlemen, hello. My name is Amir. I'm a first author of this paper. You can see the list of authors in this slide. We are going to share the paper with the title of the Large Scale Information and Communication Technology Management in Smart Cities based on Edge to Cloud. We are all from Norwegian University of Science and Technology based in Trondheim, Norway. Some information about me is available in the website you can see in this page, and also you can contact me by the email if you need further information about this paper or all related information about smart city and edge cloud. Some background of this paper is about the smart cities, Internet of Things, and also information and communication technology, we call it ICT. The main focus of this paper is about the ICT architecture. We are currently have centralized ICT architecture in smart cities, decentralized to centralized ICT architecture in a smart city, and also distributed to centralized ICT architecture. Therefore, we are going to present each of those in this paper, and we also propose our ICT architecture in this paper, and we go some details about our use case and some implementation experience we have in the Norway. We are all sharing in this presentation. Centralized ICT architecture, as you can see in the down layer of this architecture, all the data will collect from the city and send it to the cloud computing through the network communication. So all the centralized uh, technology will be used in the cloud to manage the data and also software and services for the end user of the smart city. This is how we call the centralized ICT architecture. And briefly, we can say that the data collection is in the city, and also the network management is everywhere from the edge to cloud, and also data management and resource management will be happen on the cloud computing. And also the software service management is on the top of the cloud computing. Recently, we proposed this distributed to centralized ICT architecture, as you can see in this figure. So the things layer available in the city, uh, including all the devices which are able to collect the data, is in the things layer. For instance, you can see the camera and you can see some other IoT data sources. When the data collected by the IoT data sources, they send to the fog layer. Fog layer normally is like a gateway or some kind of switch and router. They have some capacity of the storage and uh, processing, so the data will go there. You can see we have the different fog area layer, and this fog area layer is responsible to the particular uh, particular district of the city. So when the data collect by the fog layer from the down layer of the things layer, they go to the middleware system we designed by the cloudlet layer. So the cloudlet layer is like a zone of the city, maybe is responsible with the multiple the district of the city. So in this middleware platform, we are able to communicate with different cloudlet available in the city. That's why we are calling the distributed to centralized ICT architecture. Just for information, in the decentralized to centralized ICT architecture, we cannot have communication with the node in the edge of the network. So all must be handled and organized by the cloud computing. But uh, this architecture based on the clouded layer and the facility of the clouded layer, they make our middleware platform more intelligent, and we are able to communicate, and most of the requirement can be handled in the middleware platform without any communication to the cloud computing. So in the middleware platform, we are also able to communicate with the cloud as well as communicate with the bottom layer in the fog layer. As you can see in the left side of this architecture, this is coming from the very small scale to the very large scale of the city, and also lowest level of the latency is available in the fog layer, and when we go to the up, the highest level of latency comes to our communication. And also you will see that the capacity of the resource ICT resource is in the cloud computing at the highest level. Also, when we are saying about the anomaly detection and the cybersecurity risk, the main risk, the high level of the risk can be seen in the edge layer. The main focus of this paper is about the large-scale IoT and ICT management in a smart city. Let's say, what is the IoT and ICT management in terms of the large scale? When we are saying the large scale IoT and ICT management, we are focusing about the huge amount of the data will be produced by the city IoT devices and also non-IoT devices. We are also emphasizing about the time and location of the produced data. We are also emphasizing about the scale and the location of the produced data. When we are managing all this large scale information and data from the city in the centralized place, sometimes it's very tough to manage all aspects of the large scale IoT and ICT management. In this slide, we are going to present something about the main issue about the large scale IoT and ICT management. You are saying you are looking in the slide, we are saying about the data and database management issue and challenges. When we are going about the data, when we are saying about the data and database management, we are saying about some details information about the data types. As we know, we have the different data types in the smart city, like the fixed sensor data, portal sensor data, city consumer data, and also the web data. Fixed means the fixed IoT devices in the city. For instance, the sensor can be fixed in some part of in your city and collect the data. Portal, like the vehicular network, the sensor is not fixed in a particular place. Just you are turning around the city and you collect the data. City consumer data means, for instance, the city hall data or the police station data. This is available in the database of the consumer of the smart city. Web data is also, we know that all the data produced by the web and the user, they use the internet. Mainly the fixed sensor data can be available in the fog layer in our ICT architecture. Portal sensor data is also mainly in the fog layer, but city consumer data mainly available in the cloudlet layer, and also the web data we consider they can be available in the middleware platform, that is cloudlet, or in the cloud computing. Also, the data flow and movement in this kind of architecture is important, can be bottom up from the fog layer to the cloud, or can be top down from the cloud to the edge. And also cross-cutting means in the middleware platform we can also communicate with the layer. That's how the data flow and movement will be in the ICT architecture. We are also more challenges about the data aggregation, how we can aggregate the data in the large scale IoT, how the storage can be from the edge to cloud, data discovery, and also the data management. We have some implementation, and we will inform later about that. But this is all the challenges of the data and database management, and we already have some experience in this paper and also the other paper if you follow my research papers. The data and database management also go to the decentralized to centralized data management, distributed to centralized data management, and how the database can be managed in the larger scale of the IoT is also a big question. Resource management, how we can manage the resource ICT resource management in the smart city. We have different steps in this slide. We show that how we can how we can manage the resources in the smart city. Large-scale IoT and ICT management also make challenges for the network communication and software and services. In the network communication, for instance, the SDN, software-defined networking, and also ICN and also content delivery network can be useful for the management of the new generation of the network communication management in the smart city. For the software and service management, when the data available in different layer of the edge to cloud orchestration, we are able to build a different layer of the services in a smart city based on the privacy and GDPR importance for the end user. In this slide, we are also sharing about the experience about the Zen pilot project in Norway. Just some information about the Zen. Zen is the zero emission neighborhood in a smart city project available in different cities of the Norway. The main vision of the Zen is the sustainable neighborhood with zero greenhouse gas emission. We have the different work packages, and also the main challenge for us, we have the different city. It's not only one smart city, and also different data type and requirement. This architecture will show that how the fog, cloudlet, and cloud can be matched to our scenario, our Zen scenario. You will see that we have, in this case, we have two different buildings in two different cities, which are Trondheim and Oslo. So each of the building has two rooms, and some of the sensors are available there. In the cloudlet, we have the HTTP API controller, and they communicate to each other. And also we have this controller in the cloud layer. So we have the different controller in our architecture. You will see in this slide how the networking of the building network with two apartments can work together. For instance, we have the Raspberry Pi for the temperature sensor, and we have the local server machine in the server room of the building. So the temperature and sensor from two different Raspberry Pi, apartment 1 and apartment 2, will be stored in the local server machine. You can see here how database and data aggregation work in this scenario. As I said, we have two different sensor data, so all go to the request handler, and this request handler work with the database, and also we go to aggregation in the edge of the network, so the redundant data and also some aggregation will be happen in the edge of the network, and the summary of them will be sent to the cloud computing. And we have the API, and through this API and web application, the user can connect to data and collect the required information. In the resource management, in our scenario, you will see that we have the middleware platform. This is how we call in the cloudlet. So the data discovery scenario can be happen in different parts of this architecture, and more information available in other publication we have. Just we want to say that the data available in everywhere, and through the net, through this scenario, we are able to manage the resources and all the requirement for the data discovery. For the network communication, we propose through the content delivery network the new addressing system. So based on the availability of the data in the location and also the time and the city, we are able to find the data from multi-level of the distributed to centralized. So this is how easy you can find the data from the different layer, even if the data available in different layer, multiple different layer, we can go to this addressing system and we easily find the data. This is for the software management. We also propose in the other paper how we can manage the software services in different layer of the smart city. As I discussed earlier, we can have the critical services at the fog layer with the lowest latency, and also we can have the city services in the middleware platform concerning the GDPR and data privacy issues, and also the general software services can be run in the cloud computing. So the conclusion and future work, we show the facility of the distributed to centralized ICT architecture. We also say something about the different available ICT architecture, like the centralized, decentralized to centralized. So we are going to develop more our proposed distributed to centralized ICT architecture, and also we consider the requirement of the zero emission neighborhood for this proposal, for this ICT proposal. As I mentioned in the second slide of this presentation, you can always contact me for the question, and you can send me an email. So I will be happy if we can have further discuss about the distributed to centralized ICT architecture and how we can develop the smart city based off the requirement of the user. This is the end of the presentation, and wish you all the best, and thank you.